integrals are opposite to each other. So if you remember, to differentiate something, you take the power, drop it down, -1 from the power. So we're going to do antiderivatives, so integration. Integration and antiderivatives are just the opposite versions of each other. If you were plussing 5, what's the opposite of that? If you were timesing by a half, divide by a half, or times by 2 would be the opposite as well. If you were finding the sine of an angle, what's the opposite of that? The inverse sign. So basically everything has its inverse. In math, derivatives and integrals are opposites to one another. They're processes that undo one another.
Cos is sine? What was that?
Cos goes to negative sine when you differentiate, yeah. So, guys, we've looked at differentiating a function to find its gradient, Ryland. Today we're going to anti-differentiate. So we're going to go backwards from a gradient function to the original function. So if I told you that f dash of x equals 4x, what could have the original function fx have been? Nope. If it was x, if it was, let me finish. If the original function was x4, the derivative would have been 4x3. What would the original power have to have been in this one? Squared. So if this was my original function, f of x would had to have equaled x squared. And if x squared differentiated and became 4x, what would have had to been in front of it? 2. So is that 100% what my original function was?
No,
There could have been an extra value. Because would this, so 2x squared does differentiate to 4x, right? That's 100% true. But so does 2x plus 8. So does 2x. Okay. Oh.
plus or minus 1 to infinity.
What about plus 8.1? And I was. I love that in this math methods class we're asking the big questions about life, the universe, and everything. My hands are green because I spray painted a rocket earlier. Now I don't know if that's the answer you were expecting, but that is the truth. It's also why, because I had my finger up the rocket like that, which is why there's a line around my finger. There you go. You're getting a window into my life. Anyway, guys. In integration, what we say is that from the information we have, that bit is guaranteed, but there could have been some constant. So we just say plus c, and that represents any constant that got deleted as part of the differentiation process. Well, c can be negative, in which case it would be minus whatever the number was. C can also be 0, so there was no constant. So sometimes c is 0 as well. But every time we're integrating, we do that. We add the c to it. Now, when we differentiate, what is the general rule of thumb for a polynomial? What do we do? If I said 5x to the power of 3 and I differentiate it, what would I do? So we times through by the original power and subtract 1 from the power, right? Those are the two things you do when you're differentiating. So if I was to work backwards, what would I do to the power if I'm working backwards? So no, don't look at the rule. Don't look at the rule. What would I do to undo what I did to the power? What did I do to the power? No. What did I do to the power? I removed 1. So I've got a plus 1 to get it back to what it was. And then that's what the original number was. What did I do with that original number as well as times it through? So to undo it, I'd have to divide by that number. So if we scroll down, guys, this rule here, can you see that that symbol there, the big S looking thing, that means the integral. integral. So you know how derivative is the rate of change, but we use the word derivative to just mean I'm going to find the rate of change function. The same way we say integrate or we find the integral of. Yeah. So guys, if this is my original function, f of x, if I differentiated it, that would become f dash of x. No. This is just another weird terminology thing. If you ever see capital F of x, that means the integrated function. So I'm just going to make a little note there. Capital F of x equals integral of f of x. And then after it, we always put dx. Can anyone imagine why we'd put dx? Have we seen dx anywhere before? Change in y over change in x. Just tells us that we're differentiating the x. This one just tells us that we're integrating the x. Yeah, it's just f of x. So the integral of f dash of x just equals f of x. The integral of the derivative is the original function because they undo each other. I was just going to say, guys, with the dx stuff, if I was differentiating in regards to t, so like my function had t in it, I would write dt at the end. You guys will only ever have to worry about one variable. If you go and do maths at uni, you'll learn how to do polar like integration, which is where you have like x, y, and z all in there, and you do like derivative of x, integral of x, integral of y, integral of z. So you'll have like dx, dy, dz at the end, which is actually, you just do them in order. You just differentiate with x, differentiate with y, differentiate with z. But like I said, that's uni maths. You guys don't have to do it. It's different. It depends on. Okay, I'm just going to pause the recording here to answer your question. I'll wear it sometime. I got a OP2.
What?
Just casual. You can't be like, hey, what did you get on that last assignment? I got an A. Oh, just casually, I got an A. But you asked a question and I answered it.
I love how they kept the recording for that. So you guys know, OP2 in high school. Will not cut this out.
You know what? I'm going to leave this in purely so you guys can go back to the recording and hear it clearly. So, what OP did you get? And then I answered it and tried to move on, and yet you guys are the ones just like, oh, just casually.
Love this.
Let's do some integration, guys. So, if we have a look at our rule, if we start with x to the power of n, we add 1 to the power, we divide through by that new power n plus 1, we add plus c on the end. That's all it takes to do integrations. The same as derivatives, just in reverse. So, if I had the integral of 3x5 dx, that's going to be my original function, 3x, but I will add 1 to the power. So what's my new power? And then what do I do with that 6?
Carry.
Divide the whole thing by 6. Plus 1. So n was 5, and we plus 1 to it to get 6. So you don't need to do the plus 1 thing once you've added it to the power. Am I forgetting anything for my integral here? Plus c. Now, generally speaking as well, you would then simplify the fraction if you can, which would become x, well, that's the wrong number, x6 over 2, because 3 over 6 is the same thing as a half, plus c. And that you could also, if you really wanted to, you could write that as 1/2 x6 plus c, or you could write that as 0.5 x6 plus c. I do not care which one of those answers. So I've given you 4 different possible answers, different ways to write that. They're all correct. Whichever one you're comfortable with, I would use. That being said, the last one, 0.5x6 plus c, is probably the worst, in that if you then had to solve that, it's easier to solve stuff, especially tech-free, using fractions instead of decimals. So I'd encourage you to stick with fractions where you can. Makes it easier to solve down the line. Okay, let's look at this next one. Would anyone like to integrate this one for me? And before I go on, is there anything harder about this one compared to the previous one, guys? 3 terms, but is that going to make it harder? Nope. We just do each one individually. Same as derivatives. You know how we had derivatives, we had like an x5, an x6, and an x18. You just treat them each as their own little
So it'd
thing.
be plus plus.
Plus plus. Unless the integral was negative, in which case it'd be minus, but whatever. So I'm going to pick on Kurt Smith. Can you tell me what the integral of 3x squared would be?
3x.
Almost. What have you forgotten? Divide by 3.
Oh, we're doing
Tyson, what would 4x3 be as when you integrate it? 4x4 over 4. What about 3? Jesselyn, what do you reckon? What are we going to do with the 3?
drop it off.
Yeah. 3x to
You made it more complicated. Cody is about to leap out of his chair. No. Sky. 3x. Over 1, technically. I'm not going to worry about writing that. If I was differentiating a number, how can I get just a constant left over? What would the x value have to be to get a constant left over when I'm differentiating? So if I had y equals 3x, what's y dash? 3. So if I'm now going backwards and I say, okay, y dash equals 3, what does the original... Thanks, guys. Make sure you catch the recording. I dropped some subtle hints about, how I went in school, if you want to go catch that later. So the original function would be 3x. So if there's no x there, because when you differentiate, the x drops off. So when you're integrating and there's no x there, you add an x on. Oh, dx. You know how I set up here when we're writing so see here, I've got the integral of dx. Think of the integral and the dx as like ends of a bracket. It basically says everything between these is what we're integrating. So when I do this one, I'm basically saying integrate those values. So yeah, the 3 isn't attached to the dx. So that would be plus 3x. And of course, that would then simplify to x cubed plus x4. Oh, I almost swore. What did I forget?
Should be timbers.
I've forgotten something. C. The constant. By the way, the reason we call it C is A, it's a constant, but the official name is the constant of integration. So if you ever see in the textbook, it talks about the constant of integration. It's talking about C. Any value that could have been destroyed in the differentiation process. Okay. Now let's do this last one, guys. What would be the derivative of okay. I'm gonna write this out this way. And you'll see why in a minute. I'm gonna say f of x equals the integral of x cubed plus 4x squared dx. What's the integral of x cubed? It's the integral of x cubed.
x4 over 4.
x4 over 4. X to the power of 4 over 4. What is the integral of 4x squared? Correct. Plus 4x cubed over 3. Am I done? Plus the constant of integration, c. Now, this one does have more information though. It says integrate it if the function evaluated at 0 equals 0. What does that mean? If you think back to your assignment, when you're trying to solve for unknowns, you sub in points, right? So you sub in known points. This just represents a known point of this original function, f0. So we can actually solve for c if we know a point on the original function, is all it is. So if we sub in the function is equal to 0 and sub x equals 0 in, which is what the information that's telling us, we can then solve for c. So f of x.
You know x, that's 0.
X will be 0, yeah. So I'm going to replace f of x with 0 equals...
What is it then? C is 0.
C will end up being 0, yeah. So 0 equals 0 plus 0 plus c. Therefore, c equals 0. Therefore, f of x equals x4 over 4 plus 4x3 over 3. Does that make sense, guys? Is that a pretty alright process to follow? Yep. Any questions before I get you to have a go at these textbook problems?
So,
Mm-hmm.
4x squared plus c.
Because remember, you've got to divide through by the power plus 1. So you've got to divide through by 2, which would be 2x squared. So another way to think about that one, Cody. Yeah, the other way I was going to show, I didn't end up doing it, but saying, okay, we have some function like, if you had like y equals ax b, then y dash equals b times ax b minus 1. And you just got to like match up from one to the other, and yet find out b has to end up being 2. A ends up has to being 2 as well. Yeah, we'll call